A short time ago in a galaxy nearby, a podcast was made to inspire and entertain. Casual Space. Making space available, one story at a time. Your host with grace, Beth Mund.
Well, it is my honor and my pleasure to welcome astronaut Steve Hawley to the show. Hello, Steve. Welcome to Casual Space.
Thank you, Beth. I'm glad to be with you.
I'm so honored that you have been able to share with us this new book that you have written, Eyes to the Stars, a memoir for the Space Shuttle Generation. That really speaks to me. I am Space Shuttle Generation, and I can't believe that it's been retired now for some time. But your book walks us through and perfectly captures what this was all about. I'd love to start to jump in with you on the book, but I cannot before we talk about Artemis 2 and your input and your what observations you've made. What has been inspiring you when you're watching the coverage here?
A couple of things, I suppose. One is I remember back more than 20 years when I was sitting in meetings as we were talking about designing Orion. Back then it was part of Constellation, which was the program to take us back to the moon and then on to Mars. And so to finally see Orion fly is very gratifying. I wish it hadn't taken quite so long, but
Me too.
that's how things happen sometimes in the space program. Also, I was pleased at the performance of the SLS. And part of the success of the SLS, I think, is that Artemis used proven space shuttle hardware. The main engines are shuttle main engines. In fact, 3 of them on Artemis 2 had flown before many times. The solids are our space shuttle solids, except Artemis has 5 segments and we flew 4. The core stage is essentially the same external tank that we flew. So I think the Artemis program has a good start on reliability by being able to take advantage of the proven space shuttle hardware. Probably also a little bit jealous. I was too late for the Apollo program and I retired before Artemis was really stood up as a program. So I think it's great for the crew that there's sort of a really unique opportunity. And Orion has performed, as far as I can tell, extremely well.
Yeah.
The goal of Artemis 2, of course, was to show that the Orion capsule could support humans on a deep space mission. And I think it's performed extremely well. And a couple of minor things that we experienced in the shuttle program that aren't really a surprise. Although one of them kind of caught my attention because the crew found that they had trouble dumping the waste tank.
Mm-hmm.
And the ground thought there might have been some ice. And that led me back to thinking about my first flight in 1984, because that was exactly what happened to us.
Really?
We couldn't dump our waste tank because we had an icicle form. And that was kind of a challenging environment to be in at that point. But the good news was, after our flight, NASA started flying a backup capability so that the guys on Orion this time, even though they couldn't dump their tank, they had a backup method to take care of the problem. So that was all
Oh my
good. But I
gosh.
thought it was interesting that they had the same problem that we did.
That is interesting. Nothing like being the first, though, to be like, okay, this is a new problem and we've got to figure it out together.
Yeah, well, it was a test flight, and in our case, it wasn't really a test flight, but it was the first flight of that particular orbiter, the Discovery. And they had
Yeah.
made some changes to it to improve it over what Columbia and Challenger had. One of the changes was to remove some insulation around the waste dump port. So that
No.
wasn't in the direction of goodness. So after our flight, they went back and reconfigured it the way the other orbiters were.
Oh, good. I couldn't imagine the
In our
privacy I
case,
would
there
need
was a
to.
problem because if we couldn't get rid of the ice, it was a potential risk during reentry because it
Mm,
could come off and hit something in the back of the vehicle. Um, I don't know that Orion developed an icicle. They may have just had some ice in the dump line. But in any case, they would be less susceptible to damage if it came off during reentry.
mm.
So that's I guess a small advantage.
When I speak to folks within the industry, I always ask them, if you had the choice to go to space, which vehicle would you select? Nobody ever picks Soyuz, by the way. Uh, and for someone who's been on 5 shuttle flights, what do you think of the inside of that Orion capsule versus the shuttle? Is one more spacious? Does one have more systems that you appreciate? Which would, if you had the chance, would you fly the Orion?
I would, yeah. Uh, the the systems are more sophisticated than we had in the shuttle, um, and so it's probably a bit more capable in what it does. Now the shuttle was far more capable in the sense that um, we could do spacewalks and we could use the robot arm to capture or release satellites and um, eventually build the International Space Station. So the shuttle was extremely capable in terms of what you could do with it. It took a lot of mass to orbit and it could bring a lot of mass back down to Earth. Um, the Orion's mission is to keep the crew alive uh,
Hmm.
in a deep space environment and also perform rendezvous because the architecture for landing on the moon says we'll have a lander to go with Orion and the crew will have to transfer from Orion to the lander and then from the lander back to Orion. So um, that'll be something we still need to demonstrate. But so its mission is a little bit more limited. The shuttle was had more capability to actually do work, but the Orion it does well at what it was designed to do.
Well, I think that the images that we're seeing that are coming back are going to be all throughout our new textbooks and studied for years and years to come. And what did you think about some of the features they've seen on the lunar surface and some of the equipment they've used as an expert astronomer looking at, our universe through the lens? What did you think when you saw them switching out the cameras and using different devices to observe the moon?
Yeah, the pictures are really impressive. Part of that, I'm sure, is the skill of the crew. Part of it is the fact that we've, got more modern photographic techniques and capability now than we had back in the Apollo days. But the pictures are really amazing, and I know I was trying to feel for the crew the kind of pressure they must have been under
Oh,
during the close approach when they were
yeah.
describing features and taking pictures, and this is the only chance you're going to get. And I'm sure that they felt like, I can't, this is so unique. I can't afford to screw this up.
Oh,
And they didn't. They, by all accounts, made really important observations, took stunning pictures, and uh, it seems to have scientifically been a success. Now, yesterday I saw for the first time a photograph they took of the Milky Way, which I thought was kind of spectacular. And
spectacular.
from the,
Yes.
being able to photograph it, beyond the atmosphere of the Earth provides the opportunity to make a really stunning picture of our own galaxy.
Oh, absolutely. And Steve, I felt that pressure as well as they were approaching, and then that whole time, I was like, I was nervous for them, and
Yeah,
I'm just an observer. But
yeah.
we
No,
know
I
what
felt the
goes in.
same way.
Yeah.
I know that they, wanted so much to do it all properly and get all of the observations and photographs. And as far as I know, they did.
Yes, it's wonderful, wonderful to watch. And I'm so glad we could get your insight on that. So now I'd like to really focus on everything that you've shared in your book and start at the beginning. This thought that you've shared so well about the impossible becoming possible. and starting as a student and walking us through your early days where you were very driven to become an astronomer. Can you start us there?
Sure. It was in grade school where I developed a love for astronomy. Um, and I think we had a unit in school about science, and a small portion of that was about astronomy. But it got me interested enough that I would go to the library and borrow books on astronomy. And the thing that
Mhm.
I realized was that astronomers were different than, say, chemists or physicists in the sense that a chemist can set up an experiment and can look for the result and then change the experiment and see if the result changes and use that to uh, make discoveries about what's going on. And astronomers can't do that. We can't do experiments in the traditional sense. All we can do is look at objects in space and then try to think about what we're seeing and come to conclusions that way. And I thought, now that sounds like a really fun challenge. And so from then on, that was about third grade, I decided I wanted to be an astronomer. Then I think I was in fifth grade when Alan Shepard flew the first uh, man launch of Mercury. And I was really fascinated by the space program and putting people in space. And I knew even in grade school that the astronauts were all pilots. And I had already decided I was going to be an astronomer. I didn't want to be a pilot. So I knew there was no chance that I could ever be an astronaut. But I did think that it would be advantageous to be able to put a telescope in space, get it above the atmosphere, get it away from, city lights. And I thought, well, maybe one day they'll want astronomers to go and uh, operate these telescopes in orbit. And so I thought there was, in the back of my brain, there was this little spark of hope that, one day, if we did put telescopes in space, we'd want to send astronomers there to use them. So that's where my interest developed. Of course, it was unrealistic to think that I would ever have a chance to apply to be an astronaut. So,
And as I'm reading that in the book, it was just so fun to know that here we are, 5 space flights. And here you are, this reluctant person, knowing that you want to have this experience and study the stars, and yet maybe not in the way that you think it would land. But then you start your journey, you become an astronomer, you go through higher education, get your PhD, and off you go. You're going to cross the ocean and start what I love this part in the book, if I may, that you had this hands on experience looking through the telescope, which actually set you in a different class with some of the other classmates who were studying in theory. And here you were being able to actually observe and have that hands on experience that perhaps set you apart.
yeah, I hope so, at least at the time. Yeah, because I was an undergraduate at the University of Kansas, and they didn't have graduate students in astronomy. Uh, and so we had a 27-inch telescope, and so we undergraduates were allowed to use it. So I had real observing experience with a modest-sized telescope. And my friends, my classmates, who had graduated from Caltech and Princeton and other places, uh, where there were graduate students, they didn't have the observing experience. They might have had more advanced physics courses to take than I was able to take in college. So I thought, yeah, that gave me a bit of an advantage, and being an observer was what I wanted to do. I wanted to, as opposed to being a theorist.
Mhm. Was it 1974 that this shifted and you saw the piece of paper that was displayed outside of your work area to apply for NASA? Was that the year, if I'm correct?
It was 1976, and
Okay.
I was just starting my fourth year in grad school with the expectation that I'd be able to finish my thesis and graduate in the summer of 77. And of course, at that point in your career, while you're working on finishing up your thesis, the next most important thing to do is find a job. And so back in those days, the way that worked is if you're an institution looking for a new astronomy PhD, you would send letters out to the different degree granting institutions and say, here are the requirements. We're looking for a couple of postdoctoral fellows with these experiences. And because that was usually where a new PhD would end up as a postdoctoral fellow, somewhere working for a more advanced researcher. And I would go down to the bulletin board, because that's where these letters were posted by the secretary, every couple of days and see if there were any opportunities. I remember there was one from Kansas State, and so I applied for that job, didn't get it. There was another one from RPI, and I applied for that and didn't get it. And then one day on the bulletin board was this letter that said NASA on top. And I thought, well, that's interesting. Is NASA hiring astronomers? And I started reading, and it said that they were soliciting applications to be an astronaut candidate for this new thing called the Space Shuttle. And what really got my attention was suddenly you didn't have to be a pilot, because they were now going to hire scientists and engineers. And I thought, holy cow, I could actually apply to be an astronaut. They listed the requirements, and I met the requirements. Of course, 100,000 other people did too. But I remember dropping everything I was doing and sending away for an applications package, because I could not imagine not applying given the chance. I knew I had no hope of being selected, but at least I wanted to know that I had tried to do it. And so that's kind of how it began. I sent this applications package off, and then I didn't think much about it after that. And then I guess it was the summer of 77. And this guy shows up on campus wearing a suit, and I find out he's from the Office of Personnel Management, and he's doing a background investigation on me. So I concluded that must mean I'm still in the running at some level.
Mm-hmm.
And that totally shocked me that, I had gotten, through whatever preliminary cut they must have had. So, yeah, in the summer of 77, it looked like I was still being considered.
Yes, and here you were about to, or had you already packed up and started your observations and work in, was it Costa Rica?
It was Chile.
Chile, excuse me.
Yeah.
Okay. Wow.
Yeah, so I graduated and I was offered a job at Cerro Tololo Inter-American Observatory in Chile, and I accepted. And turns out that I read in the paper, it was August of 77, and I was scheduled to report end of September to Chile, that NASA was going to start interviewing astronaut candidate applicants. And to show you how naive I was, I thought, well, it might hurt me if I'm in Chile if they wanted to interview me. They might decide, well, that's, he's too far away, or it's too expensive to fly him to Houston. So I thought, well, I need to do something about this. And so I wrote him a letter, and I to the selection board, and I said, not to be presumptuous, but if you were thinking of interviewing me, I'm leaving the country in September. It might be worthwhile to do it before I left. And a week before I was supposed to, I guess it was 2 weeks before I was supposed to leave, I got a phone call, and they said, can you come to Houston next week? Which was the last week I was going to be in the country. And I thought, well, this is going to be terribly inconvenient.
Right.
But I
I
said,
can't
sure,
even
no
imagine.
problem.
All your stuff is packed. You've got,
Yeah, yeah,
a situation you've
I've got,
designed, you've
yeah,
planned for, you're moving forward on, and then here comes the wrench.
yeah. I certainly wasn't going to say, sorry, I can't make it.
Right.
So,
Right.
yeah, I had a good friend who was also going there as a postdoc, and he took care of some of the final arrangements so that I could go to Houston and spend a week. being interviewed and medically tested and psychologically
Yes.
tested, and
Yes. This,
it
the,
was a really interesting experience. And I remember thinking, if I never get any farther in this process, I feel like I've won, because I got to see JSC, I got to meet some astronauts. As it turned out, I got to ride in the simulator while I was there. So, that was kind of a dream come true, just to be able to, go to Houston and see,
right.
see the people that were making the space program happen.
And I wonder, Steve, do you think that set you apart and gave you maybe an advantage because you already had this attitude of, I won because I get to be here and have this experience and I'm open-minded to just being here? I mean, that is a little bit different than having an agenda and being a test pilot per se and saying, I've really worked on all these hours and I have a next step in a plan and this is it. And there's a difference there. Do you think that was to your advantage?
I think it was to some extent, but I think there was a bigger thing that happened that was to my advantage, which I found out years later. Um, when I was hired to go to Chile, what I actually really wanted to do was go work for an astronomer at Caltech who was doing the same kind of research that I was doing with my thesis advisor. And um, he was open to have me come, but he had a grant pending, but he didn't know if he'd have money. And so he
Mm,
couldn't promise me a position. And then the offer from Chile came. I accepted it. And then, I don't know, some weeks later, I found out that his grant had been approved and that he had money for a postdoc. And so now I'm wrestling with, well, what do I do? I tell the people in Chile, hey, thanks, but I'm going to go somewhere else? And I couldn't justify doing that. I felt like I had told them I'd come, and so I did. But I found out later when I was asking some of the members of the selection board that reviewed our class, I said, look, I had a good GPA, I had a PhD, but I didn't think I'd done anything that really stood out that would separate me from all of the competition. And what I was told was, well, you went to Chile. And they
wow.
thought that showed, a sense of adventure and
Oh, wow.
exploration. And I never told them that, well, that was the one job I got offered. But I did realize that if I had decided to withdraw my acceptance to Chile and go to Caltech, I probably wouldn't have been selected to be an astronaut, because that would have done away with the one thing that made me stand out, I
Wow.
guess. So
Wow.
that was I guess it was either lucky or at least it shows you, if you don't, if you stick to your word, maybe things will work out.
Oh, yes, even more so as you say in the book. And I know I'm jumping around, I'm jumping a little forward, but your theme and your advice in the book to always be open to the possibilities and, say yes and be fluid and saying yes to the things that are presented to you is exactly perhaps what's paid off and got you
Yeah.
this wonderful NASA opportunity. I'd like to ask you a little bit about, before we get into this full circle moment where you are at NASA, the identity shift of going from an astronomer now to an astronaut as you were selected, and this idea of individualism to working as a team, and how this was all perhaps maybe a challenge for you or just a different shift and how you navigated that.
Well, it was certainly a different shift, and it was uh, I wanted to be an astronomer in space when I was a kid. Now I'm selected to be an astronaut candidate, and I'm going to be an astronomer, if I'm lucky, in space.
Hmm.
But that's not the astronomer in space job that I had in mind when I was a kid. And I hadn't really given it much thought until they offered me the job, that I was giving up a career as a research astronomer, which is the one thing I had wanted to do all my young life, for a chance to be an astronaut. Um, and it'd be giving up, being a real astronomer in the sense that I had always imagined. Um, And I did worry about that some. I thought the odds of being picked were so low, it wasn't anything that I needed to think about. When I was offered the job, suddenly I realized I got to make a decision.
Mm.
And in that moment, I decided that, well, this is risky. In particular, it was risky because we were being hired into a 2-year job. And after 2 years, your job went away. Now, they may
Yeah.
decide to keep us based on how we did in all of our training, but that wasn't guaranteed. And my job would go away in 2 years. And I
Mhm.
remember being concerned that I'm going to have to show that I'm competent in a whole bunch of areas where I've got no experience at all, like flying jets.
Yeah.
And
The
uh,
reluctant pilot you become.
yeah, well, I wasn't sure I could do it, but also, you know, it wasn't something I could decline. I mean,
Sure.
I had to, I was given this opportunity. I had to take it and see if I could make the best of it. So um, I didn't dwell over it a lot, but I do remember thinking when I told Mr. George Abbey that I would come, that what the hell am I doing?
And I don't want to downplay this risk that you mentioned. And you, along with several other astronauts I've had the wonderful privilege of speaking to, like Kathy Sullivan and some other folks that, they have to decide to put their career that they've worked so hard and the things they want to accomplish on hold to step into this new role, a very team focused role where you do have to make these sacrifices and put these things aside that you were driven, researched, prepared for, trained to do, and now step into something completely foreign, perhaps not, maybe loosely tied, because eventually you did get to have your, astronomy in a very wonderful way. And we're going to talk about Hubble here coming up. But it is a risk and it is a saying yes to something without knowing. A million things can happen when you step into this job that perhaps were not planned in the job that you were trained for or had, the academic career that you were expecting. And so that risk for a lot of people is a huge, you're not just saying yes to George Abbey, right? You're saying yes to something unknown, undefined yet, perhaps, and something that requires such a sacrifice in your professional career. It's a huge moment.
Yeah, and I think that's right. And I remember thinking how different it maybe was for the pilots
Ah,
because they were all test pilots, and in a sense, going to NASA and now looking at flying the shuttle is just the next step up in the challenge of piloting. But
mm,
as you said, well, for Kathy and Sally and me and Pinky, that we were giving up what it was we had really set our uh, career paths on. Yeah, it was a chance to maybe do something unique, but it was also a big risk. And back in those days, of course, the shuttle hadn't even flown. So, what if
oh
the
gosh,
program isn't
right?
successful? Yeah, what are you
Oh,
going to do?
it's a
So,
huge risk. Your your yes was so loaded. It was such a huge yes, and I'm so glad you said yes. I want to jump now into your full circle moment, and here we are. As a young student, you imagined putting telescopes into space and later deploying Hubble. So, um, I would love to know when you were in orbit what that felt like, the culmination of this lifelong idea or something different. What was the Hubble experience like? I know
yeah,
you
well,
explain it in the book, but
yeah, well, it was interesting. I had this idea, as I mentioned when I was in grade school, about, maybe we should put telescopes in space. I didn't know at the time that a fairly famous astronomer, Lyman Spitzer, had written a paper in 1946 where he said, it'd be a really good idea to put a big telescope in space. And that paper led to the vision that it ultimately did become the Hubble Space Telescope. And so I know that when we were actually in orbit with Hubble, beginning the operations to deploy it, I was definitely thinking about how far we had come from Dr. Spitzer's paper, that now we have this big telescope in space and we're going to start using it to revolutionize our understanding of the universe. So I think I really appreciated the significance of that moment, even though we were only a small part of the whole effort to get Hubble into orbit.
A small part,
I
Steve.
remember thinking the things that I thought scientifically Hubble could do. And now looking back on it, 37 years later, or whatever it is that right? 36, I guess. Um, I was probably too conservative in thinking about the discoveries that we would be able to make. And so, yeah, it was such a privilege to have been, a small part of that.
It's still what we're seeing from Hubble. It's unbelievable. And I love in your book when you describe that what many would consider as a mistake became this opportunity and wonderful adjustment to go back and service Hubble, and how that was always in the plan. And I love that you explain that. And for those of you who are planning on jumping into this incredible book, this is one of the moments in your book. There were several moments for me that I enjoyed. Your reluctancy to, but still risk that you take to do the application, of course, even though you had your career set and you had this job in line. And then this moment as well, this particular moment where you are describing how the world perhaps saw this Hubble mission, but how you all saw it as an extension of the next step to go and service it so it can be functional and work in the way it was intended, and how different and new that was for NASA to be able to step into something where, it was started over here and it's going to continue over there. So a completely different perspective, perhaps, than so many of us at the time that said, okay, well, it's not working. What does that mean? And everyone that, held part of this mission close to their heart and trains for all those years said, well, this is simply what's next. Can you walk us through your thoughts on how that servicing mission was just perfectly designed and implemented?
It's worth remembering that originally the idea was we would deploy Hubble, and then every 5 years or so we would go get it and bring it back to Earth, where it would be upgraded and refurbished and then relaunched. And that idea didn't last very long because there was too much risk in bringing it home and relaunching it, and so it was decided that we would service it in place in orbit. Now that's easy to say,
Hmm.
but it's not as easy to figure out how to do it. And so, unfortunately, after we put Hubble in orbit, it was discovered that the mirror had a problem. And the problem specifically was something called spherical aberration, which meant that the mirror surface was ground to the improper shape. And that meant it could not ever be as good as it was supposed to be. And I remember, how devastated we all were. We on the crew, of course, but also at NASA, that, the promise of this instrument, had been compromised. Fortunately, not by anything we had done, but in the manufacture of the
Hmm.
of the mirror. And so we had to figure out, what are we going to do? How can we recover? We always had in mind changing out components, and some of those components were designed to be changed out by astronauts in spacesuits wearing pressurized gloves. And over time, we ended up changing out stuff that was not intended to be changed out. And that was pretty challenging. But the fact that we had in the plan the ability to go back to Hubble with the space shuttle and astronauts who could do spacewalks, and clever engineers on the ground that figured out, here's a new device we can build, and if we install this device, it'll compensate for the error in the surface of the main mirror, and it'll correct the spherical aberration. And I remember at the time thinking, well, I wasn't on that crew. I was on the second servicing mission crew, but this was being reported in the media as the most important mission since Apollo 11. So there's a lot of pressure on everybody because there was so much at stake. Um,
Sure.
and of course, history recorded that the things went well, and the mirror problem was compensated for, and uh, new solar arrays were installed. And that was just the beginning of how the engineers and the operations specialists over time figured out, what do we need to do and how can we do it to keep Hubble state of the art. Um, Now, of course, I'm jumping ahead a bit, but after 2009, we don't have the capability to service it anymore. But it's still a state-of-the-art instrument because of how we were able to upgrade it during the times when we did have the space shuttle.
An unbelievable experience altogether. Just, I don't think people really realize how incredible it is to rendezvous with anything in space and capture it and service it and have that success. All parts of that is just pretty phenomenal, pretty incredible to do. And to have some of those engineering solutions designed on Earth and brought to space, then implemented in space, fantastic. Really, it's such a great part of your experience and stories. And I loved reading that in the book. And I wanted to ask you a little bit more about risk versus the culture of risk and everything from space flight to your career saying yes to it and the opportunities, but also what you point out is the long waiting in between. So you have this intensity with the risk that you have to learn how to fly in the T-38s and learn to work with a crew that you've never perhaps worked with before. All these risks along with long periods of waiting where you have to add value and find ways that you can enhance your team on the ground and support them as you did throughout the years. So could you share with us that dynamic of risk and long waiting, both occurring oftentimes at the same time?
Yeah, the uh, risk was real, and um, I, I told people that. I mean, I think that's a decision you wrestle with before you say yes to Mr. Abbey. It's not something that you suddenly, you're 3 or 4 years into your career and you go, this turned out to be risky. uh, um, so, yeah, but the other forms of risk too. That is, uh, you know, could I learn to work with career military officers? I don't know that I even knew any military officers before I was selected. Um, Fortunately, everybody had a great deal of respect for what the other people had done. And so that turned out not to be an issue. And I learned over time that, yeah, scientists and test pilots tend to approach things a little bit differently,
A little bit.
but we can work together and ends up being a good team. Um, the other thing is, and this was important to me when subsequently I sat on the astronaut selection board and I was interviewing the people that were going to maybe come and be part of the astronaut office, is that I wanted people that felt like I thought I did, which was, my job when I'm not assigned to a mission is to do everything I can to make everybody else's mission successful. And I was looking for that trait in people that, we would interview. Is this somebody that, if it's not his or her mission, are they going to still, put 100% into making the program successful? And we had a lot of people that were like that, and that was um, important to the ultimate success of the program. Is that everybody had the same goal in mind. We were not just astronauts, but the flight controllers, the engineers. Everybody wanted our missions to be successful, and people would do whatever it was that they could do to make it so. And one of the things that I think I mentioned in the book was um, people would ask uh, me, what do you miss about NASA? And my answer was what people told me when I would ask former astronauts, you've been retired, what do you miss about NASA? Everybody would say the people. It was such a great bunch of people to work with. It was such an honor to be just part of, again, what I call the Space Shuttle Generation. I didn't make up the name, but I used it in the book.
The people. I agree. Some pretty phenomenally talented, amazing, mission-focused people. And
Right. Who are doing it for, the mission, for the agency, for, humanity, not, for something they personally get out of it, other than I'm sure they felt personally satisfied that their contribution made an impact.
And now your philosophy that you share throughout the book, and I'm sure you continue as you instruct and share and get asked all the time about this keeping options open that we mentioned in the beginning of the interview. How do you balance being decisive while still leaving room for opportunities that perhaps are unexpected? What would you say to the next generation and the people who are going to read the book and enjoy your memoir and say, okay, so how do I do this in my daily life and maybe not be in the space industry or perhaps yearn to travel in space one day?
Yeah, I guess the thing I learned was you never really know what opportunities you're going to get. I thought I was going to grow up to be a research astronomer, and it's ultimately I did when I retired from NASA. But I had no idea that I would have the opportunity to apply to NASA to be an astronaut. But the thing that made it possible was that I had tried to prepare myself as well as I could without that goal specifically being there. But I wanted to do as well as I could in school. I wanted to take hard courses. I wanted to challenge myself. There is some discussion in the book about, I came to that realization a little bit later when I realized that maybe just getting by wasn't enough. And, kind of be conscious of what's going on so that if you see something that looks interesting and new, you can look into it and see, maybe is this something that I hadn't thought about, but it might be a good fit. But it really boils down, I think, to preparation, being prepared in terms of what you learned, but also being prepared in terms of your discipline, your work habits, the you can figure out how to say this properly. I mean, you can get by as a crew member by being able to follow the checklist and do what the ground tells you to do. For me, that was never quite good enough. I mean, yes, I'm going to do what the ground tells me to do, but I wanted to understand how the systems worked. I wanted to understand in detail how the software worked. I wanted to, when we had a problem, I would have an idea about how to deal with it. And for me, that was fun. I enjoyed that, but I thought it was important to be as prepared as you can be. And again, that's being demanding of yourself, knowing what you do well, knowing what you don't do well, knowing what you know, knowing what you don't know, figuring out what you need to learn. And it took me a few years to learn all that, but those are kind of the things I share with my students is how to, make the best of your abilities and opportunities as they come along.
And yes, thank you to that teacher who challenged you right in the beginning. I love that you named him, if you'd like to say his name here too, because that was a pivotal moment for you.
It was. Yeah, Mr. Lewis was my 11th grade physics teacher. And that was a lesson that I learned because my goal going into his class was I wanted to get an A for my transcript so it would help me in applying to colleges. I got an A in high school physics. And yes, he gave me an A the first semester, but he had checked in the comments section of the report card, capable of better work. And of course, that's something my father had to sign.
Oh,
And
no.
so I had to ask Mr. Lewis about it. And he said, well, he didn't think I was working up to my ability.
Yeah.
And I said, well, I was working as hard as I needed to get an A in his course, which was stupid. And so he said that I had one of two choices. I could convince him that I was working as hard as I could in his class for the next semester, and I would get an A. And if I couldn't convince him, I would get an F. And I realized, not at the moment, but sometime later, that he was right. I had already decided I wanted to be an astronomer. And so in taking the physics class, my goal should have been to learn as much physics as possible in his class. But that hadn't been my goal. My goal was to get an A, and I didn't have to work too hard to get an A. And a couple of times later in my NASA career, I had a similar opportunity where, I could get by doing it in a certain way, but I wouldn't learn as much as if I did it differently. And that's also a lesson that I tried to share with some of my students is, again, take advantage of the opportunities you have to learn stuff.
What a great moment. What a great teacher that saw your capabilities, challenged you, required you to rise to the moment, and it
I
all
did
paid
give a
off.
talk once, many, many years ago, to 5,000 high school students made up of classes from central Kansas. And by then, Mr. Lewis had moved to a different school, but he brought his class to my talk.
Did
And I
he?
told that story with him there with his students. So he had heard me tell it now in person,
Oh, I have
how grateful
goosebumps.
I was for what he did for me.
Oh, and as you have done now for thousands of students as well, I'm sure,
I hope so.
inspiring us. Absolutely. Well, is there anything that you'd like to leave us with, either from the book or from your experiences in space that I didn't get a chance to ask you?
Golly, I'm sure there must be. uh, no, I guess, it's just been such a privilege and I do think I wrote this in the book, to have been entrusted with assignments that I got, not only the spaceflight missions. For an astronomer, it was fabulous. 3 of my 5 missions were telescopes. And so even though I wanted to be an astronomer working with telescopes in space, I got to do that. It was not exactly in the way that I had imagined. Um, so I was blessed at being given the opportunity to do that, being able to work with some of the most dedicated, hardworking people that I've ever known, um, to be able to represent the agency and the U.S. I did have a little story in the book about when I was in Chile. I was easily recognizable as an American, and I was stopped on the street one day by a local gentleman who asked me if I was an American, and I said I was. And he told me that he had first seen television in 1969 and had watched the Apollo 11 mission. And he said that was the most amazing, remarkable thing he'd ever seen. And that was really the first time that I recognized that people around the world actually pay attention to what we do. And, at least as far as this guy was concerned, this was the most impressive thing he had ever seen. And I was really, really touched by that, what America did made such a difference in this guy's life. So when I joined NASA, that was one of the stories I kept in mind because, I wanted to do things that would help, bring good recognition to NASA and the U.S.
You certainly did. You did. And I'm so grateful for this book and for your time. Thank you for sharing these stories with us today.
Oh, thank you very much.
Oh, it was such a pleasure. So, if people would like to get a copy of the book, it's coming out soon. By the time this is released, it'll be like a month away, and they can find it anywhere that they order books.
Yeah, and there's a website you can go to drstevehawley.com And there's a
Perfect.
link that'll let you look at uh, look at some of the book and order it if you feel like it.
Perfect. Well, thank you. Thank you so
Thank you, Beth.
much. All right, we'll see you again soon. Thanks for joining us.
You bet. Thank you.